Hey, what's up? Let's do some math today. In this video, we're going to talk about solving advanced inequalities. So, in case you haven't noticed, what we've been doing is we've been building up our equation and inequality solving skills. I like to say a lot of equations are just variations of x plus 1 equals 2. And what we're going to do here is same idea. A lot of inequalities are something like x plus 1 is less than 2. A lot of the ideas that we're applying to equations and inequalities are going to apply here with advanced inequalities. So a couple of things. One, I want to kind of start off by talking about a couple of big ideas. First idea is that we have to remember to flip the inequality when we multiply or divide by a negative. That's the big one. And again, we've done that before. All right, so that shouldn't be new to you, but just remember that still works. Second one, and now this one becomes a little more important at this point, is that the direction of your inequality matters. And here's what I mean by that. If I'm doing some work solving an equation, and let's just say I get 3 equals x, in my next line, I might just swap it very casually and say x equals 3, box it, walk away. But now let's think about this with like, hey, 3 is greater than x. And I just like to see the variable on the left-hand side. I'm old school like that. I just have to make sure that the direction of my inequality is still expressing the same idea. So I'm going to say x is less than 3. So notice how the pointy end right there is still pointing towards the x. So again, the pointy end is going towards the x. If we're going to flop things around, move things to the left and the right, we can. All right, but we just have to make sure that the direction is still conveys the same idea. 3 greater than x is the same thing as saying x less than 3. And you may have heard me say this before, but one thing I like to kind of think of is I like to think of peeling a sticker. So now put your hand down like on the table or on your leg or down on something in front of you, and then pick up your thumb and flip your hand over. That's what's happening here. We're taking an inequality and we've peeled the sticker, we've flipped it upside down, and that way the inequality means the same thing, but it just looks a little bit different. So just keep those in mind, and let's do 2 quick examples here. So let's go purple. All right, so just like we would deal with equations, we're going to approach these the same way. Nothing I'm going to do on my left-hand side, but I will distribute the 6 here. So 2x minus 7 is greater than or equal to 6x plus 24. Now, I like to keep my variables positive, so I'm going to subtract 2x from both sides, and I'm going to subtract 24 from both sides. That way, all my variables are on the right-hand side, and all my numbers are on the left-hand side. Ultimately, that's the goal. Variables on one side, numbers on the other. All right? But now that we run into the situation where I was just talking about the direction matters. So I have negative 31 over 4 is greater than or equal to x, which means x could be thought of as less than or equal to negative 31 over 4. All right, I've peeled that sticker. The pointy end is still pointing towards x. The open end is going to the number. I have not changed the idea of the inequality. I have changed how it looks. So that way I can put my variable on the left. Over here, let's take a look at this example. We have 2 options. We could distribute, but I'm noticing that 9 plays very well with 3. So I'm going to divide both sides by negative 3. And by doing that, my inequality needs to flip. So notice how it's not less than, it'll be greater than negative 3, 2x minus 3. Now, a couple of things I want to point out. Be careful. Negative 3, you might think if you're going to add them, they might double down. In this case, they're going to disappear. So I'm going to add 3 to both sides. And I have 2x is greater than 0. For whatever reason, anytime 0 is thrown into the mix, that tends to confuse some students. Just divide by 2. And 0 divided by anything is still 0. So that's how we would go about solving these. Again, it's very similar to what we've done with equations. We just have an inequality sign, and so we have to be mindful of the direction, and we got to be mindful of times where we need to flip it, like there. Now, since we're talking about advanced inequalities, we are also going to have to talk about solutions. Now again, we've already dealt with normal. 2x plus 3 is less than 5. We get that. We know how to do that, where you just have x is less than some number, or x is greater than or equal to. 95% of the problems we're going to do are going to be related to that. But the no solution and infinite number of solutions, that's where we have to be careful. And it's a little bit different with inequalities. Now when it came to equations, and this still holds true, the variables have to cancel out. This only will matter if the variables are gone. And the big thing we're looking for is a question. True or false? Let me show you what I mean. 2x plus 5 is less than 2x minus 3. My variables are going to cancel out, subtract 2x from both sides. 5 less than negative 3. Is that true or false? That is a false statement. Because 5 is not less than 3. So since it's false, no solution. I can't plug anything in there that will make this inequality be true. All right? But now let's keep it very similar. 2x plus 5 is greater than 2x minus 3. Subtract 2x from both sides. 5 greater than negative 3. This time, this inequality is true. And since it is true, I'm going to have an infinite number of solutions. So again, the way this works, most of the time, we're going to have a normal solution type situation. But if the variables cancel out, it's all about asking, is the statement true or is it false? If it's true, infinite number of solutions. If it's false, no solutions. So good luck on your practice, and let me know if you have any questions.